Okay, proportionality. Today is 1P2P4, if you're keeping track that way. You might want to write that down top of the page. 1P2P4. That's the worksheet we're going to be doing when we're all done. And let's make sure you understand how this generally works. Would you agree if I found a little tiny pinky bone in, like, let's say an archaeological dig, that probably went with a little tiny person? Right? Bone's really small, person's really small. You find a leg bone, it's obviously going to be bigger, but relatively small thigh bone means relatively small person. Opposite's true too. They have found that there were some civilizations a long time ago that where the people were really tall. You can measure out their thigh bones and they should be about 9-foot tall people. Okay? Now, you can make an equation for something like that. And it goes something like this. It's just a brief example. If you have a small, let's say that this is the pinky bone, and this is the height of the actual person. If it's a small pinky bone, it's going to be a small height. You know what I mean? Like both of these numbers are kind of small. If they had a really big pinky, it would be like down here, then they'd be really tall, and it'd be like that. And do you get how there'd be kind of a line of dots that would go like this? Okay. So if you measure it, it's not a perfect correlation, but they actually have this for forensic people. Like, say that heaven forbid, somebody finds a bone in the woods and it's a human bone. That's a big deal. You don't just like get to keep it at home on the mantle. It's considered a crime scene until they figure out what happened. Okay, because the human body's not supposed to just be laying around. So anyway, they can take that bone, they can take it to a chart, and they can say, oh, according to this chart, it says that this person was 5 foot 10 inches tall. And that narrows it down a little bit. Unfortunately, that's a really common height, so that wouldn't help very much. But all right, so what we're going to be doing today is called creating a regression line. And that's a line that fits this set of data the best. And I'm going to go right through like that and see how that's a line that fits well. In math, it's kind of funny. The English teachers always try to correct us on this, but its official title in the book is The Line of Best Fit. This is funny. The English teachers one time had to like grade some kind of math project we had, and they were like, no, it's the line that fits best. No. Actually, in math, it's called the line of best fit. Anyway, this line of best fit is called a regression line. So if you wanted words for a title for today, it's called regression. All right, and this regression line goes through these 2 points. And let's say, I'm going to keep the numbers really simple. Of course, it wouldn't be this way in the real world, but let's say it's 1 comma, if you had a 1 inch long pinky, you would be, let's say, 4 feet tall, which would be 4 times 12, which would be 48. 1 comma 48. What that means is if you had a 1 inch long pinky, you'd be 48 inches tall. Okay? Now, on the other end of the scale, of course, let's say that you had a 2 inch long pinky. Let's say that you would for just the bone in the pinky, that'd be really big. So maybe that person's going to be like 8 feet tall. So I'm going to double my 48 and make it a 96. See how my 2 data points there, the 1 comma 48 and the 2 comma 96? Now, there's a fancy way that the calculator can take all of the data points in between into account. The calculator has a way of factoring all of those points in and getting the line to be more and more and more accurate. Do you get that the more data you have, the more accurate you can be? All right, so we could do this, just you and I, with our brains. This is 2 points, and I want the equation of a line. You should know how to do that. You know how to find the slope. Y minus y sub 1 equals m times x minus x sub 1. Do it right now. No calculator. Actually, you can use the calculator, but just use it to like do the simple little, like finding the slope part maybe or something. So you're finding me an equation for this. When it's all done, it should look like this, except filled in. Slope comes out pretty nice because of the points I chose. going to go up here and do the slope. Slope is, you go 96 minus the 48, and that would be 48, over the 2 minus the 1, which would be 1. So slope's 48. Yay. So this is a 48. And then you put in either point you want. Tend to go towards the easier one if you have a choice. I'm going to go with the 148. You could have used the other and it'll be fine. Y minus the y of it is 48 equals m, which is 48, times x minus the x of it, which is 1. Because I was using this point right here. Raise your hand if you got the same thing, even if it's the other point. Okay, good. All right, good. We made a regression equation, but do you get that it only had 2 points on it? And therefore it's kind of primitive? The calculator can do a really cool one with a linear regression equation. So now, you need to get your calculator out, get it on, and find if you can, see if you can remember where the lists are located. I'm not going to tell you yet. You see if you know where they are. I want to find list 1 and list 2, and we're going to put data in to a list. Pausing for a second while I get my calculator ready. Okay, we're back, and I've got my calculator up here. Is it under y equals? Is that where you find your lists? Nope. Everybody, just for a second, go to mode. We haven't talked about the mode, and this is the first day using the calculators. Let's get your modes in the right places. This is not the right places, by the way, because we don't want it in sequence mode. That's a holdover from higher algebra class. We want it in function mode, func. And you get that everything's on the left-hand side of the two choices. You always want the one on the left, except for one thing, and that's radians versus degrees. It's only when you get to calculus that you'll leave your calculator in radian mode. Not even all calculus teachers do that. But in here, we for sure use degrees way more than we use radians when we're typing in the calculator. So, okay. Question? The radian is this little thing. They're big, like a big set of degrees where this distance and this distance are equal to this distance right there. That's equal to that's equal to that, and that's a radian. It's about 59 degrees. Each radian's like 59 degrees. You'll learn more about that later, but for right now, keep your calculator in degree mode, okay? All right, so you in the right modes? Okay, good. Now, go second quit to get out of that and clear off your screen. Now, does anybody have any ideas where we'd find the find these? What do you think, E? All right, second stat. Interesting. Look at that. There's a whole bunch of lists. Now, but if I do that, if I hit this, it's just going to say L1. It doesn't let me put anything into the list. So you're close. You're really close. But I'm just going to clear that out because that's not what I was really looking for. You're close, though. Hit stat. And you don't see the list yet, but what do you think we're going to do? Hit edit. Stat edit. Now my lists L1 and L2 already have some stuff in them. If you're like me, I don't want you to by accident delete a whole list, so I'm just going to show you the safe way to do this. We're just going to type right over this list. Okay? So actually, for L1, we are going to put in 1, 2, 3, and 4. For L2, I'm going to put in 2, 4, 6, and 8. I'm going to pause for a second while I handle kids that have tech issues. All right, we're back. And now we've got our lists already. We've got some numbers in there. And this is just like we had typed in X and Y. These are my X's and these are my Y's. Do you get that? Isn't that kind of logical? Okay, now I got a whole bunch of points and my calculator can tell me where the linear regression line is that goes through those points. The line that fits it best. The line of best fit. And that is found under, now go back to stat again. You may think, well, I'm already in stat. Trust me. Hit the stat button. And now we don't want to edit things. We've already got it edited. We want to do calculate. Now try to remember this stuff because it's on the test. You're going to be tested on this. You'll have to know how to use the calculator. We'll practice it a bunch of times, but don't just think, oh, we're doing this once to show you. This is how you're going to do it on the test. All right? Calculate. Now it says 1 variable stats, 2 variable stats. None of these look like a linear regression. Do they? Do you see one? Ooh, number 4 says lin reg. So everybody hit number 4. And lin reg. Now, if I've got this, if I just hit enter, it worked because it knows I put the data in list 1 and list 2. It assumed I would do that. Okay, if you want to be fancy and put it in on list 3 and list 5, you can do that. Then you would have had to tell it which lists to use. But it will default to list 1 and list 2. So as long as you did it the way I did it, you put it in list 1 and list 2, then it should have given you an answer just like this. AX plus B. Now let's interpret this a little bit more. It says AX plus B, where A equals 2 and B equals 0. Doesn't this look a lot like Y equals MX plus B? It's just that the stupid TI company decided to not use MX plus B, which the whole rest of the math world uses. I shouldn't say that. There's a few companies out there that use, like textbooks, that use A instead of M. Well, anyway, so it's a pain in the butt, but we got to, in our head, say, oh, the A, that's just like the slope. Okay, so on my line, the slope is 2, and what's the B? The Y what? The Y-intercept. The Y-intercept is 0. So if I was going to graph this thing, it would be able to be a slope of 2 and a Y-intercept of 0. So that would look like slope 2, intercept is 0. It goes like this, kind of steep. There we go. There's my line. It gave me the equation for the line of best fit. Now here's the thing that's really powerful about getting that equation. Remember that whole like thigh bone is this big, the human must have been that big. Okay, it's not going to always be nice simple numbers, right? It's not going to be the numbers that they give you. They're going to give you an unusual other number. Like for instance, if I said, in that same set of data that we were just using there, what if X wasn't 1, 2, 3, or 4? What if X was 13? That's like the pinky bone being 13. What's Y? Okay. So we can go into our equation and say, all right, I know the equation for this. The equation is Y equals 2X plus 0. Right? Y equals 2X plus 0. That's the equation they really gave me. Now, if X is 13, can you solve it? Isn't it pretty easy to solve? If X is 13, Y equals 2 times 13 plus 0. I'm starting to write them with the tail on them like those Europeans do. All right. So 2 times 13. So final answer, Y equals 26. So that's how you'd use the equation, is they'll tell you an X value. And you'll stick it into the equation that you found to get the Y value. All right, let's do one more example. And this one I actually want to be right from your homework. So we're actually doing a homework problem with you. So would you right now, put this away please, take your iPad, find your homework for today. I think this was P2P4. There, you got it? If you haven't got it yet, find it soon. P2, P4. I actually might have a 1 point P2 point P4. Okay. This will help us have some context for the numbers that we're putting in it, so it isn't just like, simple little numbers. These will be real world numbers. The total value Y in billions of dollars of aluminum imported by the United States each year from 1997 to 2003 is given in the table. What's the linear regression equation? Well, we have to put these numbers into our list, and our X's go in the list 1, and our Y's go in list 2. Okay? So grab a calculator, go back to stat, and we got to edit our list, right? So go to the L1 list, and if I were you, I'd type in all the L1s first, because they usually kind of go in order. They'll go faster that way. 97, 98, 99, 2000, 2001, 2003. Okay, so it starts in 1997, keep going till you hit 2003. 1997, 1998, 1999, 2000, 2001. Okay, double check yourself, because you put in one wrong point in your data, your calculator won't know it's a wrong point, and you'll get the whole thing wrong. Okay, list 2, get those numbers in there. 5.6, etc. Again, it's probably worth a quick check just to make sure you didn't goober one of the points. And if you did, you catch it now and you save yourself the point, because you'd never be able to tell by the equation. The equation will only be off a tiny bit. Okay, I think I'm good. How many of you guys are ready for the next step? Okay, good. So if you haven't got all the numbers, you can get them in quick. And then you're going to go to Stat. Remember where it was again? Calculate. Arrow over to Calculate. Now, where is it there? Fourth one down. And I hit Enter. As long as I use list 1 and list 2, I don't have to tell it where to get the data. And that one looks a little more complicated, but it's still the same basic equation. A is the slope. Remember, if our calculator developer had been wise, they would have used M right there. Y equals, that's my slope, and that's my y-intercept. Now, you can write that exactly as you see it on your iPads when you're over in Notability. You can write that answer down, but here's the sad part. I'm okay with you rounding it right here, but if you round it on the test, you will get it wrong. You need to be very careful to not round these. If you round it by like even 3 decimal places over, the answer is going to be a long ways off. So safest thing is to write down all the digits, because I can't burn you for that. But if you round it, you're risking getting it wrong. On this worksheet, I'm okay with you rounding it a couple places, so it'd be like maybe you go 0.2178, or actually technically you'd round it to 9 then. So it's I'm rounding it, minus 429.3 maybe. Okay? And anybody who knows anything about sig figs knows that that is totally not perfectly done with sig figs by any means. But the more decimal places we have, the better. So we just be safe, be careful on that. You're going to want to put that in all the way. Now I'm going to show you the more advanced way to do this. Don't change your data. Don't change your data to the next problem yet. Okay, let me show you, or if you already did, you better just watch this then. But everybody that's still got the data in, like I hope you do, let me show you the more advanced way to do it, because you're going to want the calculator to have this equation in its memory banks so that you can do a calculation with it. On the harder problems that we do later, they're going to say, use that equation you made to answer this question. And like the question might be, do you see this is about aluminum in up to year 2003? They might say, how many billions of dollars of aluminum would have been imported in 2006? Do you want to have to multiply this out by hand with that incredibly gross decimal and retype it into your calculator without making a single mistake? Probably not. So you want the calculator to have this in its brain. So let me show you how to do that. Go back to stat again. We've already got our data in here. We're going to just do this linear regression in a little more advanced way. Go down to linreg again, but don't hit enter. Now we're going to ask the calculator to take the data from list 1 and list 2 and put it in our y equals area on our calculator. Let me show you. I'm just going to jump out of this for a second. You don't have to go here, but if you go to y equals right here, do you get how you can have equations in your y equals line? That's where it's going to put the equation when we're done. Okay? So I'm going to clear my y equals out. In fact, you probably should all do this, because if you go in here and there's something in your y equals, it's going to say error. So make sure there's nothing on y1. Go to your y equals button. It's up in the top left. Make sure there's nothing on y1. It's all clear, so there's room for you to stick in. The calculator is going to slap an equation in there. But it errors out if there's something there already. Okay? So now I'm going back to stat. Calculate. Then reg. And now I've got to tell it this special way, which will put it into that y1. Here's what you do. Where did we get the first set of data? List 1. Do you see anywhere on this calculator in the blue writing where list 1 would be? It's right above the number 1. And notice it's a blue one, so it's not an alpha. The alphas are the greenish ones. It's right here. It's above the 1, L1. See how it says L1 on my screen now? Now you go comma. Now we got it to put in, take a wild guess, L2, which is right above the 2. L1, comma, L2. No, we're not done quite yet. Comma. The third thing it wants to know is, where would you like me to put this thing? And this is y1. Now, y1 is a variable, so it's stored under vars. You're in Precalc now. I know this is getting advanced, but you know, you've got to be able to handle this. Go to vars, see it right next to clear button, vars. And what kind of a variable am I looking for? I'm trying to put it in on the y1. It's a what kind of a var? Of y vars. See over on the right? It says y vars. Y vars. Is it function, parametric, polar, are on, off? Well, the only thing that makes sense to me is function, and that's right, it's function. And there's all the y1 functions, and I want y1. So let's look back at what we did here. We said linreg L1, comma, L2, comma, y1. What that's going to do then is take data off L1 and use it for x. Take data off L2 and use it for y. And it's going to put the resulting equation into y1. I hit enter. And now it looks exactly the same as last time, except now let's go to y1. Go to your y equals button. See how it says 0.21785714228, blah, blah, blah. It put in the whole equation without rounding it. Or if it rounded it way further over than you would have ever done. And it's got the x in there. There's the x, see? And then it's got minus 429 point, and then again, way farther than you would have ever known. Okay, so now that's good because that equation's in there now. So now, if I want to know what's going to happen in the year 2006, how do I do it? Go to graph. Everybody hit graph. Why can't I see my equation? We can't see the year 1997 on our equation because our graph is looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now we got to go into the window, or sorry, is it the window or the table settings? Let me think. It's, no, it's the window. The window, sorry. Everybody get to the window. Now, our x's, or which ones were the x's again? The years or the aluminum? X's was the years. So what's the biggest year we ever got to? 2000. Okay, but I want to be able to go all the way to like 2010 or 20 or something, right? Let's all go to 2020 for X max. Now the Y's. What's the biggest aluminum amount we ever had? Yes? Okay, hold on. The biggest aluminum amount we ever had was like 6 point something. So let's go up to like Y max of, let's say, well, 10's probably fine. Let's leave it as 10. Now if I hit graph, you see the line, finally? Okay, I'm going to go back to my window. If yours isn't working, get to this window. And you got to copy down the settings that I used there. And then when I graph it, it'll work. Okay, I'm going to stop for a second and help people with tech issues. So going back to window. Personally, I'm going to change it to 0 because our x's, think about this. If it's going all the way to 2000, we don't need it to start in the negatives. In fact, I might even change that to the year 1990 or something. That'll probably help a lot. Everybody change that. I think it'll make your graph look a lot better. Our x's are our years, and let's start even before our data starts in 1990 and go to the year 2020. All right, I'm going to go around and help with some tech issues now. Okay, one more thing. I had a lot of people where their screen looks different as soon as they say linreg. If that's you, you just want L1 and L2 to be there. They're already on that screen. But you have to store it says, where do you want the regression equation to store? So if your screen looked different than mine, where it said store linreg or store reg equation, you want to put Y1 right there. Okay? Again, that's if your calculator looked different than mine did after I said stat linear regression. I hate TI for changing their operating system because now half you guys have it different than me, which is just awesome. Thanks, TI. All right, pausing. All right, so now I'm going to do problem 4 with you. This is problem 4 off the worksheet. We're going to type in that data in the calculator, and I'll be right back. Pausing. All right, and that is all I have for the video.